if this is concrete is pure, so that means all the steel beam and concrete slab is locked, so they work like a composite element, right? So this is step 4. Now here is a loading part based on concrete sequence, construction sequence. So interesting thing here. So based on the construction of the building, typically high rise, um, maybe I can show them a little bit bigger because since we are dealing with high rise building, this is sections. Let's say, okay, you know what? Let me just I should buy the pen. So okay, just this is section I'm gonna draw. Typically during the construction, core construction going ahead, right? And then followed by the steel column and steel framing. It's just half of the right. Some floor concrete is poor, right? Some floor still the steel is erecting, right? So something like that. Uh, and then and then and some the where the floor has a concrete slab, then the contractor is going to erect the enclosure, right? Exterior enclosure first. So this is either could be cotton wall or block wall, right? So this is kind of general sequence of the high-rise building. So do you follow this, right? Um, so now go back to this a little bit big picture. That is a one. And then after this, we erecting, they put the cotton wall, the pattern system. So cotton wall is we treat as typically as superimposed dialogue. It's not structural elements, right? Structural element is only limited to this steel and concrete slab. That's a structural element. So we treat as a dialogue, self-weight of the structure. But cotton wall we treat as superimposed dialogue. So somehow this superimposed dialogue we have a weight. It varies. Sometimes cotton wall is 20 psf to brick and concrete block could be 80 psf or precast panel. It depends on thickness. So it's sometimes in the cotton wall glass, cotton wall is very light, but precast and uh, brick veneer concrete block wall is very heavy. But that makes this composite floor framing deflect. Let me draw the one thing. And then after the cotton wall is installed and the building is constructed, completed, and then live road is loaded on the beams on the composite framing. Um, so so I think at this point we have to check more detail, but I think it's big ballpark numbers when I okay mention about 38 inches, 360 is mostly we are focusing on under the live road that when beams deflect under the live road, right? We try to limit and apply the relatively restrictive deflection because those spandrel is supporting this cotton wall. So it's not like the our structural elements when beam is significantly deflect. This curtain wall, if this is a glass wall, we're gonna have some vertical mullions, typically every 4 to 5 feet on center, right? It's also follow and deflect, make their deflect. I'm just exaggerating very significantly, right? So, so this is happening. So when beam, our spandrel beam supporting that enclosure material, glass wall also deflect, all that non-structural elements deflect. So on the sections, typically vertical mullions is hanging, and which not here. So flow is below. I'm just yeah, hanging, and some yeah, they are laterally. Maybe I have to bring it up more detail one, but laterally support one point, gravity support on the other point. So glazing continual system usually hanging is hung at the top and laterally restrained at the bottom. So what that, between that panel to panel, I think there is some movement joint we call architecturally stack joint. So when you see the old big panel, right? This is maybe, and the big cotton wall has a horizontal elements kind of accommodate that those vertical movements due to the structural deflection or gravity deflection and lateral deflection and temperature deflection, contraction and expansion. So those are all movements accommodated by within this stack joint. Stack joint. So, so go back to this. This is too much, but the general idea, background idea of spandrel beams deflection criteria, we should consider more physical and realistic performance of enclosures. Is that enclosures, it depends on their material and their connection, all the mechanism. I think finally coordinated among the teams, but structural engineer typically apply 38 uh, in order to accommodate support or meet that performance of this enclosure. There is a guideline AISC. Maybe I can point out this design guide about this deflection criteria. So I'm gonna forward to you. If you maybe have a chance, maybe take a look at it. It's a very comprehensive document, but I think it's very important. Every structural engineer should get used to this and understand and also address deflection related issue for your project. It's too much, but does this answer your question?
Yeah, you went above and beyond. It was actually very interesting. Thank you very much.
Okay, all right. Just I think some of them is maybe, yeah, I think it's beyond our class, but try to at least maybe introduce you guys because you're gonna hear that yeah, from day one or as you practice. But go back to now, kind of quickly walk through that my comment. So now, oh, understand. Seems like you guys understand that moment release. So I think beam orientation first, and beam encoder. When you address the beam encoders, understand clearly, and depends on your floor system and electro system, your design intent. But typically, those once we choose this is just gravity flow framing, all beam encoder has to be moment released. So I think you guys already understand this. And second, then the slab and beams orientations, yes, has to be running perpendicular because that's a load pass. The metal deck only just again that one way distributor loads in one way. It should be sitting on series of floor beams. So as you can see, when you use ETAPS, some back elements, you show that direction of the metal deck. If that is a parallel, I think they cannot analyze it. Should be always perpendicular. So metal deck sitting along on the beams. And obviously girder and slab depends on which girder you're looking at. It is kind of something mostly uh, like this in the parallel. So don't I think you should be always understand that which one is the filler beam and girder. And so luckily the metal deck sit on the filler beams. So enclosure parameter wall, even though it is not always that case, but typical building, curtain wall, you adopt a curtain wall, glazing wall, sometimes precast. Even precast is made out of concrete. That's is a panel, because the panel is not continuous, right? Just basically attached to the our slab and sometimes column. So that we're not rely on that, even though concrete panel is pretty stiff. We don't rely on those panels as part of structural system. If this is continuous, like a core wall, continuous cast in place concrete has continuous um, reinforcement. Sometimes, or sometimes this core wall, like this, is strategically structurally. If we locate at like this, the part of the wall is exposed to the outside. Obviously, since this is structural elements, we treat it. It's using concrete, cast in place concrete, and as a all the reinforcements. And this is, even though this is work like an enclosure, this is a structural element. So I think sometimes it depends on, but we should more practice, ask, and then think about the structural system carefully. So here, parameter wall is we treat is glazing wall. So this is just non-structural parameter curtain wall. So we should not include that in part of our system.